Hello, so welcome back again to our channel, and we continue our discussion from our previous session. As you can relate and see and recall, we have actually discussed this problem statement, which is shown on your screen right now. So what we see here in the circuit shown, the switch was closed for a long time. So it says the switch is closed since long time. And if the switch is opened at t equal to 0, so at t equal to 0, if we open the switch, we are asked to calculate the maximum magnitude of the voltage across this resistor, that is VR. So this is what we are asked to compute, or in fact calculate. So we have actually solved this problem in our previous session. But then now the question is why again to discuss this problem? So I want to add some modification to this problem statement and then resolve it so that we together develop a better understanding of the switching circuits and how we are going to do that. So we have already seen how we have solved this problem and how we have calculated the magnitude of resistor voltage across the resistor, that is voltage drop VR. So if you are new to the channel and if you haven't uh, covered the previous module, we encourage you to look for that model. The link is given in the description box, or at the end of this video you will see the suggested video, something like that. Now, what is the slight modification I want to ask here? Instead of this inductor, I want to add a capacitor. I want to say that, let's say I have a capacitor of 1 microfarad right here. So instead of inductor, I am going to use a 1 microfarad capacitor. And the problem statement remains the same. I am given the circuit as shown. Now, instead of the inductor, I have a capacitor. And the problem reads like this. In the circuit shown, the switch S was closed for a long time. So the switch is closed since very long time. So we can see that we are talking about the time period t equal to 0 minus. Okay. Because at t equal to 0, the problem says the switch got open. So this is like switch SW is closed. Here at t equal to 0, we say the switch SW is opened. And thereafter, you have to when the switch gets open at t equal to 0, we are asked to determine the magnitude of this voltage drop across the resistor. So we are basically talking about the conditions t equal to time 0 plus, where switch is remained open, okay, because we have opened it at t equal to 0. So there are three stages. Here we have three stages that we have to analyze the circuit and calculate the value of VR. So how we do that? So at t equal to 0 minus, when the switch is set to be closed since long time, we can redraw the circuit at that time. So what you see here, I will have the same voltage source, that is Vs equal to 2 volt, which is this voltage source. And then switch is set to be closed at switch is closed. Switch is closed here, okay, as you can see. And this is the time t equal to 0 minus. And then you have this 1 ohm resistance. And then you see that you have this 2 ohm resistance across which you have a voltage of R. How about this capacitor? Remember, we don't have any inductor now. Instead, we have this capacitor. So since long time the switch is closed and the capacitor is therefore has reached its steady state position. Steady state position, it means capacitor is fully charged, and we can represent it by means of an open circuit like this. And we say the voltage across the capacitor VC is therefore indicated by VC of 0 minus. So it is the time before the switch gets open. So at t equal to 0 minus, switch is closed, and this circuit is representing the condition of the capacitor and the overall circuit at that time. So with this circuit configuration, we can simply calculate the currents and the voltages into the circuit. For example, we have got this 2 volt right here, and we want to understand what is the VC minus, which is essentially the voltage across resistor R as well. So we say that at t equal to 0 minus, where the switch is closed, we'll say that VC 0 minus, or which is equal to VR, will be calculated as, you see now there is a 1 ohm and 2 ohm are in series, and there is only voltage source of 2 volt in the circuit. So with the voltage division rule, we can calculate the voltage across 2 ohm resistor. So it will be simply 2 ohm multiplied by 2 volt divided by 1 plus 2 ohm. That is the total resistance. Simply a voltage division rule. So that gives you 4 by 3 volts. So this is the voltage at t equal to 0 minus. Is that what we want to find out? We have actually found out VR, but we are asked to calculate the VR, effectively its magnitude, when the switch is open at t equal to 0. So we are talking about at t equal to 0 minus, okay? So now at t equal to 0 plus, momentarily, let's see what is the voltage. I'm just going one step ahead. So at t equal to 0 plus, switch has been now opened, okay? And now we can calculate the VC, VR, in fact, that is what we want to know. So how to do that? So for that, I will have to draw the circuit, how it looks like at t equal to 0 plus. The circuit can be drawn like this. Let me draw it here with the same one. So now you have this, just a second, let me scroll down so that you can see it better. Oh, well, the circuit is like, you don't have to wait, just a second. Okay, so we can draw the circuit at t equal to, how the circuit looks like at t equal to 0 plus. So we'll draw the circuit here. You see now, this is the circuit at t equal to 0 minus, and this is the circuit at t equal to 0 plus. So Vs equal to 2 volts, and the switch is now open, okay, at t equal to 0 plus. At t equal to 0, we opened it actually, but we are now drawing the circuit at t equal to 0 plus. I will also explain how the circuit will look like exactly at t equal to 0. That is the time. And now you got this 1 ohm resistance, and then you have this 2 ohm resistance across which we are interested to know the voltage we are. But now look, this VC at t equal to 0 minus is 4 by 3 volt, which can be represented by a battery of 4 by 3 volts. And then you have this circuit complete. And therefore, now this voltage source is out of the picture because the switch is open. So you see simply the voltage VR right here. Let me write here. The voltage VR will be equal to 4 by 3 volts, which is in fact the voltage across the 2 ohm resistance, because this voltage source is out. Okay, so this is how we, and therefore the magnitude of the VR is effectively 4 by 3 volts, which is asked. Now, how about the circuit exactly at t equal to 0? At t equal to 0, when the moment switch is opened, as per the problem statement, we can draw the circuit plus minus, that is the 2 volt battery source, and you just got this switch open at t equal to 0. So you have this 1 ohm resistance, and then you have this 2 ohm resistance across which the voltage of VR is interested. But look, at t equal to 0 minus, this is the circuit we are starting, and then there is this voltage across the capacitor was calculated about 4 by 3 volts. okay, at t equal to 0 minus. So this is a steady state condition of the circuit and the capacitor. This is also a steady state condition of the circuit and the capacitor, because eventually this voltage source, which is representing the voltage across capacitor, will also get open circuited. So it will be represented by open circuit voltage of 4.3 volt. So it's essentially this circuit stage and this circuit stage look same, right? In the steady states. So look, at t equal to 0 minus and t equal to 0 plus, before the switch was closed and long after the switch got open. So we have the same circuit situations, and the voltage drop across the resistor is 4 by 3 volts. What happens exactly at t equal to 0? So this situation is called as transient. Transient. Okay, remember there are two stages. One is a transient in the switching circuit, and one is a steady state. Steady state, okay? So you see that circuit we are drawing here. We got this 4.3 volt across the capacitor, which is fully charged, and that represents the voltage across this one. But as soon as you open the switch at t equal to 0, the intrinsic property of the capacitor is to oppose any sudden change in voltage across it. So it will momentarily act as a short. And therefore, the VR is effectively is equal to 0 volts, because this 2 ohm resistance is shorted by this behavior of the capacitor. So that's how the capacitor behaves during the transients. If it were the inductor, as in the previous case, it would have behaved in transient as an open circuit, because it opposes a sudden change in a current through it. That's the property of the inductor. So very good points, very fundamental points about the capacitors and the inductors. And that's why they are quite widely useful elements as a passive elements in the switching circuit. So switching circuit, again, can be analyzed for the transient and as well as steady state conditions. So that's what we did in this tutorial module. Now the problem statement for you would be, just try calculating the same, repeating the same steps, what I explained throughout this video. Repeat the same state and calculate the current through this resistance, 1 ohm. So let's say like I1, okay? So give me the value of current for t equal to 0 minus, t equal to 0, and t equal to 0 plus, when there are inductor in the circuit and when there is a capacitor in the circuit. That's an exercise for you. So hope you found this video useful. If you liked it, click the like button, subscribe, share it with others for a wider reach, and stay tuned for more engaging content like this. Till then, wish you a very happy learning.